Now that we understand how magnetic fields are created, let's take a look at how they influence the motion of charged particles. When a charged particle moves through a magnetic field, it experiences a force equal to its charge times its velocity crossed with the local value of the magnetic field. This means that a particle with no charge, like a neutron, will not feel any magnetic force, and neither will a charged particle with zero velocity. The cross product here is a way of multiplying two vectors that always produces a vector perpendicular to the first two. This way of multiplying two vectors has two important implications. First, the magnetic force always makes charged particles curve around in their paths. In other words, magnetic fields tend to produce circular motion. Second, the magnetic force can never increase or decrease the speed of a charged particle. Let's take a look at what this means in our code. Here we create the same loop of current we had last time. We're also going to create a positively charged particle to come through the magnetic field of this loop. In the animation loop, we calculate the magnetic force that this particle experiences using VPython's cross product. Then we update the particle's velocity and position like we've done many times now. The trajectory that the particle takes through the magnetic field is astounding. It loops around several times, each time taking a sharper turn as the magnetic field grows stronger. Finally, the particle moves away from the loop, being carried on by the speed which the magnetic field is unable to change. This is an amazing result since there's no single mathematical function that will describe this motion. It's only visible to us thanks to the computer code. If we turn on the alternating current, things change dramatically. Because the current is flickering back and forth so quickly, the charged particle experiences essentially no change in its motion since the magnetic field is always flipping upside down. You have now learned how to model the motion of a charged particle under the influence of a magnetic force. Follow the link in the description below to find a set of activities to help you learn more about the magnetic force.